So first distance is 0.234. So in the distance matrix, we will take each point with each. So on the left we will list point 1, point 2, point 3, point 4, point 5, point 6, and on the bottom the same thing, point 1, point 2, point 3, point 4, point 5, point 6. Now, the distance from the object to itself will be 0. So from point 1 to point 1, we will put a 0, and we would cross out the diagonal because we don't need it. And next, we will record our distance. The distance we just measured is for this box right here. Between point 1 and point 2, we got 0, 2, 3, 4 feet. So I'm just going to write 0, 2, 4 here. We need to calculate the rest of the distances in the same way. There is a Euclidean distance calculator that you can find online. So if you just type in Euclidean distance calculator, you will get a bunch of them, and you can just enter your dimensions there and it will calculate the distance. So for example, if I enter 0.053 and then 0.22 and 0.28, it's gonna give me exactly that, 0.2343. So you could use such a calculator, just find it online, and then fill in the rest of these numbers here. This distance will be 0.22, 0.37, 0.34, 0.23, 15, 20, 14, 25, 15, 28, 11, 29, 22, 39. The top and the bottom of the matrix is the same, so we're just filling out the bottom portion here. So That was step 2. Step 2, we're gonna calculate the distances and record them in a distance matrix. Step 3, we will identify the two clusters with the shortest distance and we will merge them together. And when we do that, we're gonna also create a dendrogram to show at which distance those points were merged. So I'm gonna show this dendrogram here. The dendrogram will show all the points. Point 1, 2, 3, 4, 5, 6. And then show here at what distance they were merged. So let's look at our distance matrix. Which is the smallest number in here?
Only 11.
This is the smallest number, right? So 0.3 and 0.6 will be merged first. At distance is 0.11. Points 3 and 0.6. I didn't go for 0.6. This is a 0.6. So 0.3 and 0.6 will be merged at distance 11. So over here, I'm just gonna write 0.3 and 0.6. Now, what we need to do next is, this is a recursive algorithm, so it's going to keep on repeating these steps until the termination condition is reached. So it's going to place in separate cluster each point, then each step merge the closest pair of clusters. We have merged now 2 clusters, and now we need to, these 2 points are considered as one object now. And we need to recompute the distances from the rest of the points to this new object that we created now. So, as you remember in the PowerPoints earlier, some of the columns and rows from the matrix disappeared because were removed. Because we no longer have P3 and we no longer have P6 because they are 1 now. So we need to redo our distance matrix. So this distance matrix is the original first matrix, which is shown as the distance between single-tone clusters, other words, clusters that contain only one point in them. For the rest of the matrix, it shows the distance from in objects. So now I'm gonna create distance matrix 1. And in the new distance matrix, we move differently. Because point 3 and point 6 will be shown as a one object. So this is distance matrix number 1. So we have point 1, we have point 2, and now we have point 3 union point 6. And then we have point 4 and point 5. Most of the things in this matrix will be the same. The only difference here is the new column and row that we created. The rest of the numbers we can copy from this table. So again, the diagonal is crossed out because it's showing the distance from the cluster to itself. This can we copy this value? Point 2 to point 1. Did that change? Or not? Can we copy this box?
Yep.
Yes, because this box did not change. 0.24. Can we copy this box? 0.4, 0.1? Yes, so that's 0.37. Can we copy 0.1, 0.1? Yes, 0.34. Can we copy 0.4 to 0.2? Yes. Really, all of them we can copy except for this column and this column. How are we gonna fill out these new columns now? So now we have this situation.